period when there was a 14 times higher CO2 than there was today. So what does that do? What does that tell you about the sensitivity of the planet to CO2? Is it higher or lower? It's obviously a lot lower than people think. If you can have 14 times higher CO2 than we have today and still have an ice age, why are they worried about the small amount of CO2 causing global warming? This is 5,000 years ago, the temperature reconstruction. And what you want to pay attention to, once again, is where we're at. In this case here, our temperature is right here. This is where we are at present. And you can see that at various points in time, over the last 500,000 years, the temperature has been warmer than it is today. These are periods of glaciation. These are ice ages, and these are called interglacial warming periods. And there have been 5 of them in the last 500,000 years because they occur about every 100,000 years. Once again, showing that the temperature that we have today is not unique. This is a reconstruction of the temperatures from ice core samples taken in Antarctica. And the reason that I've shown this is because the sample not only gives temperature, but it also gives us carbon dioxide at the same time. And you can see that the carbon dioxide and the temperature data follow each other. Now Al Gore shows this graph. He takes and he pulls the carbon dioxide and he moves it away from the temperature. He says, well look, they correlate. See, as one goes up, so does the other. So he says that is proof that carbon dioxide causes temperature changes. But now when you put the graphs together like they're supposed to, like they're shown here, what do you see? Well, what you see is the temperature, which is the dark line, precedes the carbon dioxide. So if temperature goes up before carbon dioxide, how can carbon dioxide cause temperature? So the answer is no. CO2 does not cause does not cause temperature to rise, just the opposite happens. When in fact the Earth warms for some other reason that is not carbon dioxide dependent, that causes carbon dioxide to come out of the atmosphere, or to go into the atmosphere usually from the sinks. Most of these sinks are the oceans. So to show you briefly that correlation does not prove causation, I plotted the postal changes that have occurred over the last 100 years and the temperature of the planet. Okay? They correlate beautifully. So therefore, we can conclude that U.S. postal charges drive global warming. That makes as much sense as saying that the correlation of carbon dioxide changes with temperature. To say that carbon dioxide therefore causes temperature changes is not true. So don't be aware. Be wary when somebody gives you a correlation because they do not prove causation. Here's a 1,000-year reconstruction of temperature. Once again, it's important to note where we're at. This is our temperature right here today. And this is the warming period that we're in. We had a little ice age back in about the 1600s, around the time of the founding, where you could walk from Manhattan to Staten Island. It's called the Little Ice Age. And here, about 1000 AD or 1200, we had a medieval warming period. Once again, you can see that the temperatures that we have today are not unique. It's happened again. When it happened back in the medieval warm period, there was no industrialization. There were no cars, there were no airplanes, there were no power plants that were spewing out CO2. The CO2 was much lower. So, the warm period that we have today is in fact not unique. This represents a history, a summation of the temperature history, if you will. The temperature, when somebody says, are we having global warming, you have to say yes, because we're in an ice age and we're coming out of an ice age for the last 12,000 years. The temperature has been going up about, the slope of this line here, about 0.7 degrees centigrade per 100 years. This is the average temperature increase that we've been experiencing. However, there are oscillation periods within the slope that go up and down. These are called multi-decadal oscillations, and there are explanations for why they occur. And what happens is every 30 years, the temperature warms, comes and cools down again, and warms again. And global warming fanatics will look at, in 1978, when we started a multi-decadal increase in temperature, they thought, well, look, what's happening is the rate of slope of global warming has been increasing. And so they drew a line and they extrapolated this rate of global warming. When in fact, if you look at history, if you go back and look at around World War II, we had an increase, a decadal increase in temperature that's very similar to what we have right now. So these oscillations, they will use these oscillations to fool you because they choose a baseline to draw the slope of the line. If they went back during World War II, they could have convinced you, possibly, that global warming was occurring there then as well. So be careful about where people draw their baselines. And our prediction is now that we're at the top of this multi-decadal oscillation, and we're going to start cooling trend. So maybe the next 30 years is going to be a lot more like the 30 years before in the 70s and 60s. The point being here is that we're going to keep warming at about a modest 0.7 degrees centigrade for 100 years. All right, some temperature data, summary points. Today's temperature is not unusual. We're in a warming from the last ice age at about 0.7 degrees centigrade. There are nested cycles of warming and cooling. Okay, we just saw those. The rates of temperature change are dependent on what your baseline is. As temperatures were hotter than before, the temperature is not dependent on CO2. The converse may be so. Now, what else do we know about CO2 warming in the atmosphere? When carbon dioxide or greenhouse gases cause warming, it leaves behind a thermal fingerprint. And what happens is the temperature of the atmosphere, what's called the lower troposphere, which is about 12 kilometers high, which is basically where a jet airplane flies, over the tropics, begins to warm. That warming is about 2 times higher than the surface temperature. So if you were Superman and you could fly around the globe, okay, around the equator, and you had a thermometer and you're flying at 12 kilometers, and you look at the temperature, if in fact the globe is warming because it's due to greenhouse gas, then the temperature at that altitude will be twice that of the ground. Okay, this is a prediction that we know should happen, so now let's go do the experiment, okay? The models predict this. And you can see this graph right here. It shows this hot spot at 12 kilometers right over the tropics. So what do? You run down to Ecuador, you have a weather balloon, right, with a temperature sensor on it. You float it up there, and at 12 kilometers, you register the temperature, you find out what it is. This is the actual data. The actual data show that the temperature at that altitude in the tropics is actually cooler than the ground temperature. So the fingerprint now, the heat fingerprint for global warming is not there, okay? So the data does not agree with the theory. So the conclusion is that the observed global warming is not due to the radiant forcing from greenhouse gases. It must be caused by some other mechanism. The thermal fingerprint doesn't match. People talk about climate change. Okay? We've all heard about it. If global warming is occurring, the climate is going to be more violent than it is today. Well, here's data to refute that. Rainfall over the last 100 years has stayed the same. Okay, my laser pointer at work here. You can see it hasn't changed over 100 years. Tornado intensity has actually dropped a little bit. You heard about Atlantic hurricanes. The frequency of Atlantic hurricanes has stayed the same over that 100-year period. Hurricane intensity. They tell you that the hurricanes are going to become more severe. They're not. These are the numbers of severe hurricanes in the Atlantic. They stay the same. The maximum wind speed in these hurricanes is not any different than it has been over the last 100 years. What about droughts? You can see that the frequency of droughts over the last 100 years has stayed the same.